It's time now for us to go to a completely different chapter, the chapter about vectors. Before starting, I want you to pay attention to the fact that if you are trying to solve and to find past paper questions about this, um, everything regarding the topics that are covered in lessons 1 and 2 will be found on exams prior to 2020, if I'm not mistaken, will be found on exams from Pure Math AS. The whole chapter of vectors passed to the Pure Math 3, to the A2 part of the syllabus from 2020. Again, I'm not completely sure about this year, but I think it was. It passed into the Pure Math 3. Okay, so again, if you are using exam papers prior to this date, you will find the contents of lessons 1 and 2 in the Pure Math 1 syllabus. Okay, having said that, what is a vector? You already know this from the previous qualifications that you have, that a vector is any quantity that has both a magnitude and a direction. Okay, so let's take a look at this vector v over here. The magnitude of this vector v is given by a number. In this case, the magnitude is 5. And the direction can be given in different ways. Here, I opted to put the direction as the angle that the vector makes with the x-axis, this angle over here. All right? In this particular vector, you can represent it. Actually, this is true for all vectors, but the coordinates of this particular vector can be calculated using a method that relates to trigonometry, using the SOHCAHTOA rule. And the coordinates are the values that the vector take after decomposition on both the x-axis and the y-axis. For this one in particular, the coordinates on the x-axis, or the coordinate on the x-axis, is 4, and the coordinate on the y-axis is 3. Now, how do you represent this? In most of the questions that you'll find here, you'll have either this representation or that representation. This one is a column representation. On top goes the coordinate on the x-axis, in this case 4, and at bottom goes the coordinate on the y-axis, 3 in this case. You can also see it like this: v equals 4i plus 3j. Now, what are these I? What is this I and what is this a? The I is called a unitary vector, is a vector with dimension 1. So this means that you have 4 of these as the x coordinate, and you have 4 of these, which is the unitary vector in the y direction. Not 4, sorry, 3 of these in the y-axis. This is what it means. More on what a unitary vector is later on. How do you calculate the magnitude of a vector if you know the coordinates? Well, it's simple. You see that this is a rectangle triangle in which the vector itself, the magnitude of the vector, is the hypotenuse. So you will know that v squared equals 4 squared plus 3 squared. In other words, the magnitude, the modulus of v, can be calculated doing the square root of the square of its components added together. So it will yield the value 5. What about the direction? Again, if the direction is expressed in terms of the x-axis, then you can use SOHCAHTOA, as I mentioned, and you will see that the angle can be calculated by doing the inverse tangent of the opposite side, this side, which is the same as this, so 3 divided by the adjacent side, which is the x component, with value 4, so tan negative 1 or 3/4. Okay, so again, if you know the direction and if you know the components of a vector, you can get the magnitude and the angle. If you know the magnitude and the angle, you can get the components. You need to understand that equal vectors have the same magnitude and direction, no matter where they are placed, but they are considered equal. And the coordinates of a vector or its magnitude and direction don't say anything about its location, unless it is specifically referred that the vector is a position vector. And in this case, you know that the location is the vector. That vector will start at the origin of the referential. So in this case, this vector over here, represented by OA, is a position vector. A displacement vector AB does not start at the origin, but its components can be calculated knowing other two vectors, the one that goes, or the position vectors that goes from the origin to the beginning of the vector. The other vector is the one that starts at the origin and go to the end of the vector, here represented by OA and OB. And then AB can be expressed as OB minus OA. Always the one that goes to the end of the vector first minus the one that goes to its origin. More on subtraction of vectors in a bit. Vector calculations. What calculations can you perform with vectors at this moment? Starting with the multiplication of a vector by a scalar, by a number. So if C is a number, a scalar, and V is a vector with components x, y, then C times V is going to be given in component form by C times x, C times y. Or, expressed this way, is going to be Cxi, Cyj. So you just multiply whatever C is by each component, and that is going to be these are going to be the coordinates of the resulting vector. So you have it over here. If C is a number bigger than 1, you are basically enlarging the vector. So this is basically going to be the scale factor. But you must pay attention to the fact that this doesn't change the angle, just the magnitude. If C is a value that is between 0 and 1, this is going to shrink the vector. It's still its scale factor. And again, it's not going to change the direction of the vector, just its size, its magnitude. What is a negative of a vector? Now, if V is a vector with components x, y, then minus V is just going to be minus x minus y. Or minus V is going to be minus xi minus yj. All right? What does this do? It doesn't change the direction of the vector. It just changes, it doesn't change the magnitude of the vector. It just changes its direction. It's going to be the opposite direction as represented over here. What if you want to add vectors? Let's say that you have a vector v with components x1, y1, and a vector u with components x2, y2. Then the overall vector w, that is basically v plus u, is the same as u plus v, doesn't matter the order when you are adding vectors. And the components are going to be x1 plus x2, and the y components y1 plus y2, as you can see there. So let's say that you have the vectors are these. So the overall vector is this one over here. The outcome vector is always one that starts at the beginning of the first and ends at the end of the last. In the case of adding, it doesn't matter which one you start with. As you can see here, the W is going to be the same. At least it is supposed to be. My drawing is not perfect. What if you subtract vectors? You can think of a subtraction of vector as the addition of a negative of the one that you are subtracting. In other words, if you have a vector u, if you want to subtract a vector u from a vector v, this will correspond to adding a negative of u, which is minus u to v. So w, the overall vector, is going to be v minus u, which is the same as doing v plus minus u. And this you already learned how to do before, okay? This is going to be the same as doing minus u plus v, but it's not the same as doing minus v plus u, okay? It matters which one is being subtracted, okay? So you have here vector v and vector u. If you are doing v minus u, this means what? V stays the same, u reverses direction. After all, you are multiplying u by minus 1. And then the overall vector is still going to start at the beginning of the first and end at the end of the last. This is the same as doing minus u plus v, but will not be the same. I didn't even bother to represent it here. It's not going to be the same as doing minus v plus u. Pay attention to the fact that what I'm saying here for the addition and subtraction of two vectors is valid for any number of vectors. You just keep doing this. Now that you know how to subtract vectors, we can look back at the displacement vector over here, okay? What is a displacement vector? It's going to be OB minus OA, as I mentioned before. So it's going to be this plus minus that. That's what you have over here. OB plus the reverse of the OA, which is this vector over here, AB, which is the same as that. At least it is supposed to be, okay? Let's revisit the unit vector. The unit vector is a vector with magnitude 1, as I mentioned before. And if you don't know the magnitude as expressed in terms of the overall magnitude of the vector you are starting with, you can simply find this by dividing the vector in its component form by its magnitude. The vector I, J, and the K represents the unitary vector in 3 dimensions that we don't use here in Math A-Levels. But anyway, you have there the letter that represents that. And these are the unit vectors. So let's say that you have a vector with components A and B. Then the magnitude of this vector, as you already know, is going to be the square root of A squared plus B squared. So the unitary vector on the y direction, on the x direction, which is called the y, is just A divided by the magnitude of V. And the unitary vector J in the y direction is going to be the component of the vector, which is B in this case, divided by the magnitude of the vector represented over here. This would be the outcome of dividing A by the magnitude of the vector. This would be the outcome of dividing B by the magnitude of the vector.